Hi, so today I'm going to take you through some more drawing and explain a bit more about processing. Processing has a lot of capabilities in drawing, and there's just no end basically to the things you can do, so we've got a lot to cover. So questions this week, go to Slido and type in V484 and you can ask questions which I'll answer in the lecture. This mainly comes from chapter 3 of the processing book, so have a look at that. You'll need to work through all of the material, but there's also a chapter 3 archive online as well. Now, as an example of a really interesting work, Golan Levin produced this project called The Dumpster in 2006. And this is back when blogs were a big thing, and they found a huge number of different blog posts that represented or referred to being dumped. And you can still go and use that system, which was all implemented in processing. So go and have a look at the video. You'll find the link at the bottom here, or you can go to the slides as well. That's also available. So in terms of code, what we need to understand this time around is the idea of functions. Functions or methods you may already know about from programming fundamentals, but if you don't, they're basically a little bit of reusable code. This function here, draw squiggle, is a bit of reusable code that allows us to draw a squiggle. The code to draw that squiggle goes here, and we also might want to make it reusable but also make it customizable. So we might want to draw a squiggle every time, but we also want to decide how thick the line should be, the line width. So we can give a value for the line width here. So to use this function, we go draw squiggle 20. Now, what does the void mean? Well, the void means this function doesn't return anything. So if it was to calculate a number and return that number, you could say give me the value of this function and use the function to calculate the value. But in this case, we just want it to draw a squiggle, so it's going to draw that on the screen, and then it's not going to calculate anything after it's finished drawing. So let's have a look at that. Here is an example of some code that does exactly what you're looking at. So we have a function called setup, and then we have draw squiggle. Setup says set up a window, make the background white, I don't want to fill, and stroke is black. Then it says draw squiggle 10, and it says draw squiggle 5. So it does it twice with two different line widths, if you remember. Now, here is the actual code that does the draw squiggle thing. We'll go through that in a bit more detail, but you may remember vertexes. So there's a lot there. Stroke weight. Now this is set to the line width you've asked for. You asked for a line width of 10 or 5 or maybe even 20, and the command stroke weight sets that line width. Then we begin shape, and we set the first vertex at width. What's that width of? Well, that's the width of the window and the height of the window divided by 2. So that's going to be half, right in the middle of the window. And then we say cx1, cy1, cx2, cy2. They're set to random numbers, and ax and ay are also set to random numbers. So we're saying Bezier vertex cx1, cy1, cx2, cy2, ax, ay. So that's basically we're starting with one vertex there, and then we're going to do another vertex. Let's have a look. There we go. Remember that each of these shapes starts from the center. So if you look, this is starting from the center, and this one is as well. And you can see that this is one squiggle. There's a vertex there, and there's some other points, control points, at different points as well. This is another squiggle which has the final vertex and some control points for the Bezier curve. A few more examples. There we go. So that's gone boing. This one's here. They both seem to cross over, don't they? What about the hi there? Well, we've got this string greeting hi there. It says fill black, 0 is black, text size is big, and then text greeting at point 3030. So that's up in the top left-hand corner there. That's about where we expect it to be. We can change the text size to make it bigger if we want to. Whoa, goes off the screen. Okay, so if you want more information about functions, head off to see Dan Schiffman. He's a very enthusiastic character. You can get that link from the slides on UTS Online. Now you've seen setup and you've seen draw. In most cases, you'll see a setup and a draw function in every processing sketch, and you should use one too. So in setup, you do things that you only need to do once, like size 400 400 to set the window to 400 and 400, and background 100 to set the background gray. The draw function runs every time processing outputs to the screen. So every frame is drawn once per frame. So if you have 60 frames per second, that means there's only a few milliseconds to draw each frame. Now if you want to draw new things to the screen, you want them to move and you don't want to draw over each time, you need to reset the background each time you draw. So that background 0 basically blanks the screen out and makes it all black. Then you say rectangle mouse X, mouse Y, 100, 100, and that will draw a rectangle that is 100 pixels wide and 100 pixels high at the position mouse X, mouse Y. So let's have a look at that. That's draw demo. Here we go. We've got void setup size of the window. Didn't set the background there because it's going to be set straight away when it starts doing this loop. So let's have a look at this. Okay, you can see, if you look closely, you can see as I move my mouse I sometimes beat the rectangle, but when I stop it catches up straight away. So that is an example of using interaction. Because we're redrawing this rectangle every time, mouse X and mouse Y are changing with mouse interaction. So we've used quite a lot of predefined shapes. Rectangle, for instance. We've made triangles, we've made ellipses, and we've also made some points. So that's fine if you just want to use shapes, but you probably realize they get a bit boring fairly quickly, and we can't do really interesting things with them most of the time. Sometimes they're useful though, but a lot of the time we want something else. So how do we make custom shapes? Well, you've already seen this a little, but to do this we say, well, we're going to put one point here and another point there, and then we're going to join them up just like the old dot paintings, where you say start here, go to here, go to here, go to here, go to here, etc. So you need to give each of the vertexes in order, and you can give as many vertexes as you like to make a shape. But at the end of the shape, you need to say end shape. So this little function here says begin shape, vertex x, y, vertex x, y plus h, which is the height, vertex x plus width, y plus height, vertex x plus width, just y, and then we're done. And we go back to the first vertex. So let's have a look at that. That's rectangle plot. There it was. Rectangle plot. Okay, so here we have size 600, 600. Background 255. Is that white or black? That's white. Plot rectangle 100, 100. Now that's the position to put the rectangle. And then 400, 400 for the size. So let's draw that. There we go. So begin shape. Now remember, this is the first value. This one is the y, the second value. 400 is the width. And 400 is the height. So x and y is 100, 100. We come down from the origin. 100, 100. That's 100 in, 100 down. So that's x and y. The second vertex is x, y plus h. Now height is the fourth one, so it's 400. So the first one's x, that's 100. And then y plus 8, so that's 500 down here. So this is the second vertex here. Going first vertex, second vertex. X plus w and y plus h is 100 plus 400 and 100 plus 400. So that's this one here. That's down, that's in 500 and down 500. And then the last vertex is here, x plus w. So that's x is 100 plus w is 400, so it's 500. And y, which is only 100. So that's the last vertex. 1, 2, 3, 4 vertexes. And then we say end shape, and we go to the end here. So we can change these values. Let's change this to 150, and we're not going to get a rectangle if we say that. We're going to get something else. Not that one. So we will get a rectangle actually. It'll just be not a square. We're not going to get a square because we've changed the width, the height, so it's not the same as the width. We can move it around, make this one different, and we're just going to do the vertexes as we've specified here. Okay?